title of this work is called Generative Adversarial Network. The title is taken from the actual algorithm, the machine learning algorithm that is used to generate many of the images here. And it's important to know a little bit about how that algorithm works to understand where the images come from. So in the way that machine learning neural networks operate is that you first must train them with the data set, and then they can, in the case of a generative adversarial network, they can start to generate an image based on the set of the data set that it is trained upon. So what the goal of it is to create an image that looks exactly like one of the images that it's trained on, but not an exact copy, just one that has the aspects and color and form of those. So these have been used to create celebrity headshots. They've been used to create interior architecture shots, and they can all these models then can endlessly generate imagery that looks exactly like what it's trained on, but not an exact copy. So in the case of this piece, the Generative Adversarial Network, and the reason that I wanted to use that title is because I find it's a very interesting name for an algorithm, and simultaneously I came across a data set, an open contest on a website called Kaggle, which is owned by Google, which is in itself a very interesting sort of website for contests about machine learning using Google's algorithms. And so on Kaggle, the Transportation Security Administration, the TSA, which was formed by George Bush after 9/11 to sort of create a safe and secure environment in America's airports, had installed these millimeter wave scanners. So you might have seen them where, or, you know, if you've passed through the United States or any of the other Five Eyes countries, you've had to stand up and be scanned by a giant robotic arm that goes around, and what it does is it sees through your clothes and tries to see if you have a weapon or drugs, or if you're an adversary, if you're part of that adversarial network. So I thought that that was an interesting turn of phrase. And rather than use this data set to identify where weapons or drugs might be hidden on a person's body, I took that data and had the machine learning algorithm begin to create its own imagery. So what you're seeing on the smaller screens is actually the process of the machine learning to create the images. So the way that a GAN for short, we can just call it that, it's a Generative Adversarial Network, or GAN as it's commonly referred to. It will start with a random image, just white noise, as if it's on your television set, and then send that to what's called the discriminator, another half of this machine learning algorithm. The discriminator will say, that doesn't look anything like the image that I've learned, so it sends it back to the generator. The generator changes things ever so slightly, sends it back. The discriminator half will say, yes, that's a little bit better, keep going in that direction, or no, it's actually gotten worse, take a couple steps back and start over. So when you look at the smaller images, you'll see they start to have the form of the body as in the larger scan, and then they kind of break apart and disintegrate and constantly are sort of renewing. And so what you're seeing is this machine beginning to imagine or beginning to create its own adversaries, as you see in this larger monitor here. Interestingly enough, funny to do the interview on this day, but the first AI, they're calling it the first AI artwork, was sold at Sotheby's today using the very same algorithm. A French group, I don't remember their name, but they trained what these are, this network is commonly used for, this machine learning algorithm is used for. They trained it on a set of Renaissance masters painting portraits, and then they asked the machine to generate a single portrait, printed that out on canvas, put a fancy frame around it, and Sotheby's sold it for like $430,000. So it's kind of a crazy thing, but rather than make art that is just a copy of some Renaissance portraiture, I feel it's really important to try to somehow reflect what these algorithms are kind of used for in today's sort of technological infrastructure. And this, this is just kind of a gesture to make visible some of these invisible kind of networks and this idea of what an AI may or may not be doing to decide who's a threat or who isn't. It can even invent its own threats, which is what it's sort of doing here.